Hi everyone, this is Mrs. Wickard. I am going to be making a video on even and odd functions. It's going to be the lesson that you will be watching while the other half is taking the test. Miss Fabrica and I are sharing this video. We basically roll out the same lessons for you guys. So she did her part with the exams and I'm doing my part with the video. I'm going to share. We'll be doing that all through the year when we make these videos. So let's get started. I asked you to print out this worksheet, and if you didn't want to print it out, you just want a copy, that's fine. This was our first do now, and basically it's going to help us introduce even and odd functions, which is something that you did learn last year, but it was one of those topics that you studied for all of maybe 2 days, maybe for 3 days max, so you might have forgotten. So we're going to just review everything today. In our do now, it's asking us to write g of x as a reflection of f of x in the y-axis. Well, as soon as I see that I'm looking for some sort of reflection, I know something has to be negated. It's either going to be a negation on the outside of the function or a negation with the x inside. So then I look further and it says reflection in the y-axis. Well, the reflection over the y-axis is when we negate inside. So I'm going to write f of x, and instead of writing just x, anywhere I see x, anywhere, let me go back to this pen. Anywhere I see x, I'm just going to put a parentheses, and I'm going to fill those parentheses with the transformation of a reflection in the y-axis. So you're going to see a negative x go inside, a negative x go inside. And so when we do that, they asked us to simplify your answer. So you actually want to perform the operation. So f of negative x is going to equal, when you have a negative x squared, that's going to be positive x squared. So guys, remember, order of operations, exponents first, then you multiply. So this is going to become negative x squared becomes positive x squared, and you're left with 3 times positive x squared, so it's 3x squared. And this is 4 times negative x, which is negative 4x minus 1. And last but not least, they told me to name this new reflection over the y-axis the function g of x. So this is it. G of x is equal to 3x squared minus 4x minus 1. And if I look, it's not exactly the same as the original, is it? All right, so that's something that we're going to be doing in this lesson, is just going to compare the final answer with the original. But in this case, they just literally asked us to remember what the rule was. How do we reflect in the y-axis? We negate the x. Okay, so let's move on to the lesson of even and odd functions. And what I presented here is the rule that you should have walked away last year knowing, that if you have what we call an even function, and I just want to be clear right now, even function is very, very, very different than an even degree. An even degree refers to the largest exponent in a function. So that talks about end behavior. Even function is something different. In an even function, we say this rule is true. The rule is that when I plug in negative x, I end up getting the very same as the original, which was not the case in the do now. So in the case of the do now, I could say, oh yeah, that's not an even function because I just plugged in negative x and I didn't end up with the original. For an odd function, they told me the rule is that when I plug in negative x, I don't end up with the same, I end up with the complete opposite, because there's f of x and there's the negative. That's telling me it's the opposite. So regardless, whenever I'm trying to decide, do I have an even function or do I have an odd function, your first step is to always plug in f of negative x and then decide what's your outcome. Your outcome, if it's exactly the same as what you started with, the original of f of x, well, that's called an even function. If I plug in, again, always plugging in that negative x, and now if I plug in that negative x and I end up getting the complete opposite, well then, that means every single term changes signs. Well then I can say this is an odd function. Now what happens if I don't get the completely the same or completely opposite? Well then it's what we call neither. It's neither going to be even or odd. So let's just go back to that do now, and now I'm going to ask another question. I'm going to say, is this an even function? Oops. Let's go back to this pen. Okay, back to this. Is this an even function or is it an odd function? Well, that requires me to look at the final answer after I plugged in the negative x, which is right here, and I compare it with the original. When I compare it with the original, the first term's the same, but the second term is opposite. That right away tells me this is neither even or odd because it's a mix. In order to be odd, 3 would have had to been negative and that 1 would have had to been positive. Every single term would have had to be changed. All right, so let's go to the first question after examining the rule of even and odd functions. When I look at this and this question is now asking me, is it an even, odd, or neither? Why? Okay. You might have learned little tricks in the past, something to deal with exponents. I'm not going to repeat them, but I think that some teachers might have said if all the exponents were even, it's an even. If all the exponents are odd, it's odd. And remember that constant is an even. I said that super duper fast because I don't really want you to remember it that way. It's not going to help you. And remember, this is the class that really preps you for AP Calc. And AP Calc, you absolutely have to be able to read these types of notations, right? They're not going to tell you have an even function. They're not going to tell you have an odd function. They're just going to say, hey, this is true, or this right here is true. And from there, you have to go, oh, that means that it's an even function. That means that this is an odd function. And certain characteristics will be true. So let's check. If I want to know if something's even, odd, or neither, my very, very, very first step will always be the same. It will be my job to plug in f of negative x, plug in negative x, and see what happens. So this is the original. Wherever I see x, I'm taking that x out, and I'm plugging in negative x. And now we simplify. If I take negative x and square it, that becomes positive. Any negative raised to an even power becomes positive. So it's positive x squared, and then I just bring down that constant plus 4, and I'm left with this. So now it's my job to decide my outcome after I plugged in negative x, is it exactly the same as what I started? It sure is. So I can now state that f of negative x was equal to f of x, the original. Well, we just said that rule means that it is even. This function is even. So when you say, to answer the question why, you will say this is an even function because, I'm so sorry about my handwriting with this, because f of negative x equals f of x. That is a proof. That's a justification. Okay, now you try the second one. And I'm going to pause because I want you to pause this video and try it yourself.